All right, today we're going to build something, but forget about hammers and nails. We're going to use a super precise blueprint, a set of rules, to build something that's, well, perfect. You're about to see how a few simple instructions can create a flawless and powerful pattern.
So, how do we build a perfect number machine? Well, let's think of it like a quest. Our mission, should we choose to accept it, is to build this special machine that has a very specific job, and this is the key. It can't ever fail. So where do we start? We start with its mission.
You know, every great quest needs a hero. And for us, our hero is this function that we're going to call the sequential integer string generator. It's got a simple purpose, but the way it does it has to be absolutely perfect. So let's take a look at what exactly it needs to do.
Okay, so here's the deal. Our hero's official name is number pattern. You give it just one thing, a positive whole number. We'll just call it n. And its one and only mission is to hand you back a string of text, counting up from 1 all the way to whatever n is. That's it. Simple, right? Now, the blueprint is also really specific about the tools our hero gets to use. To pull off this mission, it has to use one very specific, very powerful tool, the for loop. I mean, it's the perfect choice for a repetitive job like counting, right? And this part is totally non-negotiable. It's in the plan.
So, what happens when everything goes exactly right? You know, in the world of development, we call this the happy path. It's that ideal scenario where our little generator gets the perfect input and just nails its mission flawlessly.
Let's just walk through a quick example. Let's say we give our function the number 4. Okay, so it gets that number, and right away it kicks off its for loop, starting at 1. It grabs that 1, adds it to a string with a little space after it. Then the loop keeps going. It moves to 2, adds 2 and a space. Then 3, adds 3 and a space. And finally, it gets the 4, adds 4 and a space. And since that's our target number, the job is done. The loop stops.
And boom, there's our final result. The treasure at the end of this happy path is that perfectly formed string. 1, 2, 3, 4. It's simple, it's elegant, and it's exactly what the blueprint ordered. Mission accomplished. But what happens when things aren't so perfect? I mean, any good hero has to be ready for some unexpected challenges. Our generator needs to know how to defend itself against bad inputs that could totally derail the whole mission. So the blueprint points out two main dangers. Over on the left, we have the wrong tool. This is what happens when someone tries to give our function something that isn't a whole number at all, like a decimal or maybe even a word. And on the right, the wrong territory. This is when the number is just too small, like 0, or even a negative number. To fight off that first danger, our hero has a very specific shield. If the input is not an integer, it doesn't even try to do the job. Nope, it stops right there and sends back this exact message. Argument must be an integer value. And this isn't just some random rule. It's a huge principle in good coding. Always check your inputs before you try to use them.
And for that second danger, we've got another safeguard in place. If the number is an integer, but it's less than 1, so 0 or a negative number, the mission is called off again. This time, the generator sends back a different, very specific message. Argument must be an integer greater than 0. This makes sure it only works in valid territory, which is another key to writing safe, predictable code.
So, we've seen the main mission, the perfect happy path scenario, and the critical safeguards. Let's put it all together now and take a look at the final, complete blueprint that pretty much governs our hero's entire existence. So here it is, the whole shebang. We have the function's name, number pattern. We know it absolutely must use a for loop. It's got one clear path to success. Give back that string of numbers if you get a positive integer. And it has two very clear paths for failure. What to do if the input isn't an integer, and what to do if it's less than 1. See? This blueprint literally covers every single possibility.
So why does all this matter so much? Well, because having a detailed blueprint like this is what makes our little number machine so powerful. It's not just about getting the right answer some of the time. It's about being reliable, predictable, and robust. It can handle whatever you throw at it, every single time, without surprises.
So we have our complete blueprint, and it's designed to be super reliable. But it kind of makes you think, doesn't it? What if the number n was just gigantic, like maybe too big for the computer to even handle? Now that you've got the blueprint, what other kinds of safeguards would you add to make this thing even more bulletproof? Something to chew on.